Next, through a mathematical example, we review how to solve first-order linear differential equations with constant coefficients. First of all, let's discuss the linear relationship. The so-called linear ordinary differential equation refers to the linear relationship between the derivative item of the variable and the variable itself. If the coefficients of the linear relationship are constant, then it is ordinary differential equation with constant coefficients. If the highest order term of the equation is first order derivative, we call it the first order. After finished all the definitions, we will introduce the solution of the equation. We need to guess how the expression of xt might be. After the derivation and the plus itself times by a coefficient, it is 0 at last. Obviously, it is not okay if xt is a polynomial, because its first order derivative is the x term. And plus them, it cannot be equal to 0. Next, is that okay if xt is equal to sine t? Its first order derivative is cosine t. Cosine t plus 2 times sine t is also not be equal to 0. Next, we guess that xt is equal to exponential term, that is, xt is a times e to lambda t. X prime t is lambda a e to lambda t. Then the equation can be written as lambda a times e to lambda t plus 2 times a times e to lambda t is equal to 0. We know that e to lambda t is usually not equal to 0, so it can be cancelled. In general, a is also not equal to 0, so a also can be counteracted. So the equation becomes a linear algebraic equation about lambda. That is, lambda plus 2 is 0. It's easy to get lambda is minus 2. What does that mean? It means that xt is a times e to negative 2t must be a solution of the equation. So we guess out the solution form of the equation. In the previous analysis, we call such equation the characteristic equation, whose solutions are called characteristic root. The equation only has the expression on the left of the equal sign, and is 0 on the right. We call it a homogeneous equation. For such a homogeneous equation, we have found the solution with the arbitrary coefficient a. The solution satisfies the homogeneous equation. We call it general solution. If the equation has the initial condition, suppose x0 is 1, we can substitute the initial condition into the general solution. Then we can get a is 1. So we got the solution of the first order linear algebraic with constant coefficient. Under such an initial condition, that is, xt is e to the minus 2t. Sometimes the right side of the equation has an expression with t. Such equation is called an inhomogeneous equation. For the inhomogeneous equations, because the differential equation is a linear equation, we can divide its solution into two parts. The first part is and the second part is if we know that x is x prime plus x double prime, the contribution to the equation of this part is to make the left item is equal to 0. while the contribution of this part is to make the left item is equal to the right one. So it is a solution of the equation. The reason for the division is that we have successfully found the homogeneous equations. We can easily know the solution of the equation is I prime is equal to a times e to minus 2t. So now we need to find a solution which meets such an equation. What kind of solution can meet this equation? We continue to guess. What is x double prime t can meet its first derivative plus 2 times it of itself is equal to t2, 2. Naturally, we can guess that x double prime t is a quadratic item. That is, x double prime t is equal to a times t22 plus bt plus c. Then d double prime t dt is 2at plus b. Substituting them into the equation, we can get 2at plus b plus 2at squared plus 2bt plus 2c is t22, t squared. By comparing parameters, we know that a is 0.5. Similarly, b is minus 0.5. and c is 0.25. So we get that x double prime t is 0.5 t squared minus 0.5 t plus 0.25. With the results that xt is equal to 0.5 t squared minus 0.5 t plus 0.25 plus a times e to the negative 2t. It constitutes a general solution of an inhomogeneous ordinary differential equation with constant coefficients. The reason we call it a general solution is that there is an underdetermined coefficient in the solution. Similarly, if it has an initial condition, suppose x0 is 1, we can get 0.25 plus a is 1. So a is 0.75. Thus, we get the final expression of xt. So the solving of the inhomogeneous ordinary differential equation with constant coefficient is completed. It should be noted that in the final solution, x prime t is called as general solution. And the x double prime t is called a special solution. Here we use two practical equations as example to simply introduce the solving process of the ordinary differential equation with constant coefficients. If you are interested in this part, you can refer to the textbooks about differential equation or calculus. The contents discussed above is enough for the study of dynamic circuits.